Hello, folks, and welcome. I pray that you're doing well. I'm on the up and up. Today, I want to talk about simple and compound interest. So, get yourself a pencil and some lined notebook paper because the pencil is the tool of the mind. And anytime that we're thinking, we should be writing things down. Writing helps us to think, and we should be thinking when we're writing. Good writing is evidence of good thinking, and maybe even a calculator too. We're going to do some computation today. I've got my trusty TI-30, solar powered. Life is good. All right, so let's see if we can get the extended screen rolling here. You should be seeing, oops, I got to pull the paper over. There we go. Simple and compound interest. Okay, so here's a question for you. Would you loan your little brother 20 bucks? So let's say that your little brother came to you and said, "Oh no, I need to borrow $20." And you want to know a couple things. Number one, what's it for? Not cotton candy. How long will it take him to pay you back and things like that? And he says, "Oh, I needed to fix my bike because the only way I have to get to and from work to earn more money is on my bike." And you say, "Well, that's a pretty noble cause." Um, and so you loan him the money. Here you go, little guy. He says thank you and goes off and does his thing. I can't get him out of the frame, so he's just going to have to hang out over there. And so after a while, maybe it's a week, he comes back to you and says, "See, I'm trustworthy. Here's your money." And he gives you your money back. And maybe if he's like a really good little brother, like he'll give you back an extra $2 or something like that. Oops. He'll give you back an extra $2 because you didn't charge him any interest, did you? Right? You didn't charge him a fee. Well, maybe you would if he's a brat. I guess that depends on how good a little brother he is. But he, as a means of thanking you, he gives you two more dollars. So you get your $20 back. He gives you two more dollars. You've made 10% interest. And that's essentially how a loan works. Maybe you wouldn't charge your brother interest because, he's a brother. But banks do. That's how they make their living. That's how they make their money, is they charge a fee for borrowing money. So let's talk about a couple terms here. The amount of money that is borrowed has got a special name. That's called the principal. Not a principal, PLE, which would be like a guiding rule or something like that. The fee for borrowing money is called the interest. Interest. And usually it's just a percentage of the original. So in the example that I just gave, 10% of 20 is 2. That would be a fee for borrowing the money. And there's usually always an issue of time. How long is it going to take before the payment's done and we're back to squared away again? That's usually called the term of the loan and so forth. So let's see here. If you go to the bank and you say, "Hey, I want to borrow not 20 bucks, but you want to borrow $10,000." Okay, so the principal, capital P, $10,000. They might know what you want to buy or what you want to borrow it for. Are you going to be, buying baseball cards or bubble gum or something like that? You're like, "No, I'm starting up a business." "What's your business plan?" "Oh, that sounds good." They won't just loan you the money for any old reason. And you want to have an interest rate of, let's say, 5%. Okay, and let's say that you just do it for 1 year. Okay, so you're going to pay everything back in a year. I'll come back in a year and I'll give you your money back plus a fee for borrowing it. That would be the interest. So the question is, how much is your interest? Interest is just a very simple mathematical formula. Interest is equal to then the percentage as a decimal. What's 5% as a decimal? 0.05. And then multiplied by $10,000. And so what's the interest fee that you pay back? Now's the time to reach for your calculator. Hmm. 0.05, not point 0.5, right? That's 50%. 0.05 times 10,000, you're going to pay back an interest of $500. $500 is the fee that you pay for borrowing the money a year later. So in the end, the final amount that you pay back to the bank is going to be the principal plus the interest. You're going to pay back the $10,000 plus an extra $500 to the bank for borrowing it. So what do you pay back the bank? $10,500. Okay? Does this make sense? What if you said, well, I need more time to pay that back. Can I pay you back in 3 years? The bank might say, no, you can't borrow $10,000 at 5% interest for 3 years. It's got to cost you more than just $500 to borrow that. And you say, well, what if I pay you back $500 each year that I borrow it, every year? The bank says, oh, yeah, we'll take that. That's a pretty good thing. So that's the term. The term is now more than 1 year. So the time then, we'll say, is 3 years. And so now let's go back up here and modify some of this. The amount of money borrowed is the principal. That's usually in dollars. The fee for the borrowing the money is the interest rate. And that's usually per year. So it's called APR. Maybe you've seen that like on a bank sign or something like that. APR, annual percentage rate. Every year you pay that amount. Well, it doesn't change the situation all that much. You're just going to be multiplying 500 now by 3. Okay? So there's actually a pretty squared away formula for this. It's just simply this. The interest then, and maybe you've seen this if you've taken like a 6th or 7th grade math class or maybe algebra or something like that. The interest is equal to the principal times the rate as a decimal multiplied by the time in years, where the rate is an annual percentage rate. So how much interest would you pay here? Interest is equal to, well, you try. Press pause on the video and give it a shot. Okay, time's up. So let's see, it would be $10,000 times the interest as a decimal, 0.05, and then times 3 years, because you're doing it 3 times, right? I mean, that makes sense. So go ahead and start from cold. Let's do this. 10,000 times 0.05, then times 3. You pay back a total interest fee of $1,500. That's just the fee that you have. You still have to pay back the money. So the final amount then is equal to the principal plus the interest, which is going to be what? $10,000 plus $1,500, $11,500. Now, this formula here can change a little bit. Maybe if you're algebra savvy, you can say that it's principal plus the principal times the rate times the time, right? See that final amount? Right? Because the interest is the principal times the rate times the time. And if you know a little factoring, you can do a factor thing and say the final amount is the principal times 1 plus the rate times the time. And so maybe that's the formula that you might use in an algebra class or something like that. Right? Does that make sense? Now, that's just a very simple thing where you borrow the money, and then when the term is over, you come back and you pay it all in one big lump sum. Most banks, though, won't let you do that. What they want you to do is they want you to pay it back slowly over time. And so if we're doing 3 years, they might want to make you pay back a monthly amount. Every month you pay part of it back. Okay, all you have to do is just take up the total amount and divide it by the number of months for your monthly payment. If that's the total amount that you have to pay back in the end, the $10,000 plus the $1,500 interest, you just simply have to divide this by 36, right? Because 36 months in 3 years. So 11,500 divided by 36 months. What does that give you? That gives you about $319.45 to round up, because the bank will round up to the very last day. That's how much you would pay then per month to pay that all back. And that's usually how a car loan actually works. If you ever buy a car by taking out a loan for it. What they do is they run the percentage, and 3 years, 4 years, 5 years, and then they give you a monthly payment amount, and that's your car payment every month. You can make the monthly payment less by extending the time, like borrow it for 4 years, or borrow it for 5 years, or borrow it for 6 years. I think even sometimes now they have 7-year car loans. Oh, it gets the monthly payment down really, really low. Yeah, but you're paying an extra year or 2 or 3 worth of interest, and so the final price is like really, really high. Is it worth borrowing $10,000 when you have to pay the bank an extra $1,500? You may decide it's not worth that, even if the monthly payment is lower. But sometimes, dun, 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 the bank pays you. Yeah, that's always a better idea, right? Because where do the banks get the money to loan money to you? Where do they get the money? Out of their pockets? No, they get other people that loan them the money. Maybe you could be the one to loan banks the money. So let's say this. Let's say that the tables are turned and you're going to loan the bank money. The simplest way to do that is with a CD, or a certificate of deposit. Maybe you've seen that before. CD, it's a certificate of deposit. What that does is you loan the bank a certain amount of money, and usually it's in the thousands of dollars. You have to have a minimum amount. So maybe you loan the bank $5,000. You're going to loan the bank $5,000, and you need to do it for a set amount of time. And usually it's not. Usually it's years. So let's say that you're going to loan the bank $5,000. You're going to loan the bank that for 4 years, and the bank's going to pay you 7% APR. I'm just making these numbers up, but they're not far from off. And so then that's the money that the bank gets to loan other people. Now they're going to charge other people more interest, right? And the difference in the interest between what the borrowers pay the bank back and then what the bank pays you back, that's the money that they get to keep. That's how they do their thing. But you have to wait for it. Okay? So the interest here just follows the simple interest process. The interest is equal to the principal times the rate times the time. So the interest here is going to be $5,000 multiplied by 0.07 as a decimal, remember, and then times the time, 4 years. Press pause, run your number for that. I get an interest payment of $1,400. So what the bank will pay you back then at the end of 4 years is going to be $5,000 plus $1,400 as their fee to you. So you get paid $6,400. You say that's nice. You come back on that day and you get your money back. Now sometimes you can get your money out early, but there's penalties and stuff like that because the bank doesn't want it. Like, hey, you made a contract. But it's my money. I want it now. Okay, well, we're not going to pay you so much interest. There's an early withdrawal fee or something like that. And that's a simple certificate of deposit. Sometimes you can do this sort of a thing where you loan folks money, businesses, or maybe even banks, or maybe even the government or something like that, and they don't pay you the interest back at the final maturity date. That's when the term of the loan is over. They'll pay you back over a period of time. They'll make you small payments of interest. You don't have to wait until the very, very end. So let's say that the bank pays you once a year. You're borrowing the money for 4 years, but you want to get paid interest every year. So all I'm going to do is take $1,400 and divide it into 4 years, and I get a payment of $350. So if you take that interest and divide it out, you get $350 every year. So here's what happens. Let's draw a little timeline here. Timelines are cool. So this is the start, 0. Here's 1 year, 2nd year, 3rd year, 4th year. Here's the end. So what happens is you take your $5,000 and you give it to the bank and say, I'm going to let you use it. What the bank does is the bank will make you a payment of $350 at the end of year 1, and then they will pay you $350 at the end of year 2, $350 at the end of the year 3, and then $350 plus your $5,000 that you loan them back in the end, so that you're not waiting 4 years and getting nothing. You're getting a regular interest payment over time. And that's typically the kind of investment that would be like a bond. They make regular intervals. Now you don't have to do it just once a year. Like they could say every 6 months, right? Which would be half of that. So if you want to get paid every 6 months, they're going to pay you like 175 every 6 months, 175, and then 175, and so forth. And over time, they've paid you back the full interest, and so forth like that. Okay, does this make sense? Now, here's the thing. What do you do with the interest? So all this is just simple interest. You're like, oh, I got a check for $350 from the bank. Christmas money. All right. Every year we're going to spend $350 on Christmas money or something like that. You could take it and go spend it. Take it and go spend it. Take it and go spend it. And so if you're looking for an investment that actually pays you a regular amount of money, that doesn't change how much you've got, like you've always got your $5,000 running through the system here, and you'll get that back in the end. This gives you a regular cash payment, okay? You can go spend it. You can go live on that, although $350 is not much to live on. But what if you did this? What if you said, what if I took that and reinvested it and just rolled it? What would that look like? That's compound interest, and that's very interesting. Let's do this situation again, but we'll do it a year at a time. You realize that each year you're getting paid $350, $350, $350, $350, or whatever. Okay? Let's do this again, but we'll do it 1 year at a time. Year number 1, what have you got? You've got your principal of $5,000, and you've got your interest rate of 0.07, right? And so what's your interest payment? Your interest payment, we said, was again $350. Let's say that you just did that for 1 year. But you say, instead of taking the $350 and going and having fun with it, I'm going to take it and put it back with my original $5,000. You tell the bank, well, why don't you take that $350 you were going to pay me and like just stick it back with what I gave you to start with and start the process over again. Just let it ride, right? Let it ride. Well, that changes things now for year 2. Year 2, your principal's not $500 or $5,000. It's $5,000 plus $350. You're putting it. See what I'm doing? You're starting with more money the second year than you would have otherwise. So it's $5,350. Your interest rate's still 0.07. But what's the interest payment now at the end of the second year? It's not $350. It's going to be more. So that's going to be $5,350 times 0.07. And then we're just doing it for a year. So what's that? Get you a calculator. See if you're faster than me. I can't even get mine to turn on. You already beat me. I just know it. 5350 times 0.07. You get $374.50. Do you see how that's a higher interest rate than you would have gotten the second year if you roll your payment back into the principal? It's not $350 the second year, it's more. And you say, hey, let's just do it again. So you take your $374.50 and you roll it back into your principal here. And so now year 3, you start off with more principal. I can't do that. Plus $5,350. $5,724.50. Okay. What's the interest? Your interest rate's still the same. So what's the interest payment here? $5,724.50 times 0.07. If you run the numbers, I get year 3 an interest payment of $4.72. Hey, roll it back in and keep going. Year 4, what do you get? Your principal now, if you follow the math, $6,125.22, if I've done the math correctly. You realize you're starting with over $1,000 more than you started with the first year? You realize that? Because you keep putting your interest back with your principal and say, do it again. So, interest, $6,125.22 times 0.07. If I do my math right, I get a final interest payment of $428.77. Okay, so now here's the deal. At the end of 4 years, I say, stop, I want my money back. So they're going to take that interest payment and they're going to add it to this fourth year beginning principal, and you're going to get out a final amount of $6,553.99, which from $5,000 originally, you've made $1,553.99. That's how much you've earned. How much did you earn before? You only earned $1,400 before. Now you're earning $1,550. You've earned $150 more in interest by compounding your interest. This is compound interest. Compound interest is when you don't take the interest payment out. You roll it back into your principal and you keep going. Okay? The number of times it's compounded is going to be n. There's going to be a formula pretty soon, because you don't have to do it yearly. Sometimes you can do it every 6 months. So you're doing it twice a year. You're rolling it back in and computing the new principal and starting over. Sometimes you can do it once a month. There's even like you can do it daily. Like the quicker you get your interest payment and roll it back into your interest formula, the larger it gets. There's actually a formula for this. All that we really did here, notice we're repeatedly multiplying by the interest rate. Interest rate, interest rate, interest rate, interest rate. When you repeatedly multiply something, it's an exponent. Remember that? Right? 3 squared is 9. It means you're repeatedly multiplying 3's. So if you're going to do compound interest, the simple formula for a yearly amount, which is what we were doing, is the final amount is the principal times 1 plus r, which is the rate as a decimal, and then t would be the number of years. If you did this and you said 5,000, which is the principal, times 1.07, which is 1 plus the interest, the 1's there because you have to get your original money back out, and you did it for 4 years, you would get this number and you'd only be off by a penny. The reason you're off by a penny is because we used rounded numbers in through here. This keeps it precise. And if you've done anything with Algebra 2 or something like that, there's a more complicated thing. What if you do it more than once a year? Well, that's even better, but the formula is a little more complicated. Principal times 1 plus r over n to the nt. So it involves a little bit more algebra. But that is compound interest, and that's powerful, okay? So when you start to do investing and things of that nature, the sooner you can start investing and find things that will compound your interest, the better. Now, what we were doing is we were taking the interest that's paid and putting it back with the principal and running the process again. You can continue to add stuff to the principal like every year. So if you've got a 401k or some kind of mutual fund, IRA savings account or something like that, your investment is earning you interest, which then gets added into the original amount. Plus, you can continue to make payments in there out of your paycheck or something like that. But the key thing here is time. And with time, it grows slowly at first, but then it starts to really take off. It's got a very interesting property. It's got an exponential property. All right, I hope you're doing well. Continue to pursue goodness, truth, and beauty.